All right, welcome to period 7, my blue class. We're going to be talking about the sets of real numbers today. So this first slide here shows you the different subsets that we have, talking about rational and then irrational, and looking down through the rational at integers, whole numbers, and natural numbers. So this is a part of the foundations unit, so stuff you've already gone over probably at the end of middle school, early high school. All right, so I'm hoping that some of this will be familiar. All right, let's start by looking at the rational numbers and the irrational numbers. All right, take a look at 0.5. So we're going to see 5/10. This is a rational number because the decimal terminates or stops. Do you see how the last digit is in the tenths place? So that's why it is called a rational number. It stops. Take a look at this one down here. 5.3121212121212. Does that stop? No. But why is that in the rational section? Why would you think that it's in the rational number section, even though I said it doesn't stop? What do you think? Not because of the 5.3. It's actually the other numbers. The 1 and the 2. Do you see how there's a bar over them? All right, that means it goes on forever in that pattern of 1, 2, 1, 2, 1, 2. So even if your number doesn't stop, as long as there's a pattern as it goes on forever, then it's rational. All right. Take a look at the other rational number here, and really just the 7/9. Do you see that 7/9? That's a fraction. What math word is in the word rational? What math word is in the word rational? Ratio. And a ratio is just a fraction. So if you see fractions, your mind is thinking rational. All right. Flip to irrational numbers. What do you see in the irrational numbers? There are negatives, but there's negatives over here too on this side.
So they have
the square roots. So when I see square roots, pretty much every time when I see square roots, it's going to be irrational. Because even though we did the decimal approximation for the square root of 2 is like 1.3, if you had a calculator and did the square root of 2, would it say 1.3? What would it say if I did a calculator for the square root of 2? It'd be like 1 point and then a bunch of numbers. And then it would stop. But why does it stop on your calculator? Because the calculator can only go like 8 or 9 digits, right? But in theory, that number's going on forever. But is there a pattern?
Yes.
No, there's not a pattern. So with square roots, there's no pattern. So that's why this is in the irrational section. Does everyone see pi? What is the approximation that we use for pi? 3.14. Well, fine, you can keep going if you want, but we usually use 3.14. But is it actually 3.14? No, it's a number that goes on forever with no pattern, which is why it is irrational. Okay? How do we get from rational to integers? What do we lose to get from rational to integers? There's no more ratio, which means there's no more decimals or fractions. Those are gone. So integers are your negative, positive, and negative whole numbers, like -5 or +3. Those are integers. How do we get from integers to whole numbers? What do we drop there? The negatives, very good. So it'd be like 0, 1, 2, 3, 4, 5. What about the natural numbers? What do we drop there? We drop 0, very good. So one thing that will help you is when you think of the natural numbers, should write this down. Think of these as the counting numbers. When you first learned to count, your parents most likely taught you to start with the number 1. All right? So when you think natural numbers, you think the counting numbers. So it doesn't include 0. Now, I am going to allow you today to use these symbols, these letters, instead of writing out the whole name if you'd like. All right? But you'll notice irrational does not have a symbol. So we're going to write out irrational. Are we ready to try? Yes, Carissa. Excellent. Well, this one I know, the Q, do you know why? Well, first off, we already used R, so they had to come up with another one. Do you know why they use Q? No. Somebody said, I'm not going to name names, but a student in one of my previous classes said, well, it comes after R in the alphabet. It's not true. Okay? That's all right? That was Alondra. Okay, so then the next one What I would say for this one, let me see if I can get your brain to see this. You're going to like this. Ready? You see the fraction? Fraction is just another way to write about division. And when I say division and I see a Q, do you know the answer to a division problem? It's a quotient, which starts with a Q. So that's related to that one. The Z for integers, I like to joke and tell students that it's integers, but that's not obviously true. I think it comes from a German word for integer. The Z, yeah. Sure. Okay, let's try. Let's try 0.6. Let's go with Maddie. 0.6. What do you think, Maddie? How would you classify 0.6? Rational. Why do you say rational, Maddie? It's a decimal, and more importantly, what about that decimal? It's in the tens place. Do you see any numbers after it, Maddie? No, which means that it terminates. It stops. Okay? So that's why we call it rational. Questions on that one? Okay. The next one. The square root of 2. What do you got for me? Aviana? Irrational. And now there's no symbol for that one, so we got to write it irrational. Nice work. The next one, 0. Let's go with Josue. 0. Whole number. Excellent. That's going to use the W. The next one is -5/2. Ooh, this is a tough one. -5/2. Let's go with Emily. -5/2. Rational, very good, because you should see that it is a fraction. And our last one, 5,129 10,000ths. Whew, that's a lot. Let's go with Frank. What about that one? Rational. Thanks, Josue. All right. Questions on classifying them. Questions on classifying. Yes, Camilla.
I thought you said it like.
What did I say? What did I say? I lied. I'm just. What did I say? We got the recording, by the way.
Decimals, if it has like a pattern, then it's rational.
If it goes on forever with a pattern, it's rational.
And then it just like stops out of the tens, it's rational.
It's rational.
But you never said anything if like the numbers change like that.
Did I ever say it had to stop at the tenths? I just said it had to stop. So does it stop?
Yeah.
Yes, it just stops at the 10,000ths place. So even though it stops later, it still stops. All right? So I'm sorry. That's my bad. Clarification, my fault. Sorry about that, listeners. Okay. People listen, okay? Jeez. Let's order them from least to greatest. Give me some help here. We did the square root of 2. What was the approximation for the square root of 2? We're going to use 1.3. You can use 1.2. That's fine. All right. Remember, I would accept 1.1, 1.2, 1.3, 1.4, but I'm not going to accept 1.5. That's too high. What about for -5/2? Who knows the decimal for -5/2? Who's got the decimal for -5/2? Say 1 point? Not 1 point. 2 point. Well, let's think about this. 2 goes into 5 twice, right? Because 2 times 2 is 4. So if there's 1 left, then it's 1 over 2. What's 1 over 2? 50%, so half, 0.5. Yes? The negative cancels out. When did I say that? No, I mean, it's not a good day for me. When did I say that? I think what I told you was if there's a negative number and it's a fraction, then you have the negative goes with one or the other. And most mathematicians would put it with the numerator. You're not going to put it with both because then it's a positive. All right? Okay, let's put them from least to greatest. What's the lowest number up there? The only negative. Very good. So that's going to be -5/2. Now you'll notice, even though I asked you for the approximation, what did I write when I'm writing it in from least to greatest? The original fraction, okay? So write the original. That's a good thing to make sure you understand before we do the exit ticket to at the end of class. What's the next lowest number? There's no more negatives, right? So the next one has to be 0 because 0 comes before positive. 0 is neutral. It's not positive. It's not negative. What comes after 0? Ooh, not 0.6, 0.5129. It will be right before 0.6 because it's less than 0.6. Right? I know this, it kind of looks like more numbers. Think of it like this. What if this had 0, 0, 0? Right? If you take out the decimal, it would be like 600 compared to, or sorry, 6,000 compared to 5,129. So it's actually more, even though it's less numbers. Okay? And the last one. Well, we're going to use the square root of 2. So that's the process here of classifying as well as ordering from least to greatest. Any questions on this process? We're going to do one more together. All right. Let's do one more. Example 2. Let's start with -2. How would you classify that one, Genesis? Integer. Very good. And that one is Z, if you'd like. Ooh, the opposite of the square root of 3. This ought to be a good one. Let's go with Clarissa. Yeah, classified. It is irrational. Very good, Clarissa. All right, pi. Everyone knows that one. That one's irrational. It's world famous pi. 3/2. 3/2. What do you got for me, Nada? 3/2. What do you think? Rational. Very good. It is a fraction. It's a ratio. Nice work. And last but not least, -321 thousandths. Or -0.321. Jose. Rational as well. And why is it rational, Jose? It stops. Excellent. So, Camilla, another one of those. It stopped later than some, but it still stops. All right, next work, guys. That was impressive. Let's order it. I think we could use some help on a few of these. The square root of 3. What do you want to use for the square root of 3? For the approximation. It's pretty close to 4, right? And what's the square root of 4? Is 2. So it's not going to be all the way to 2. So personally, I use -1.7. If you use -1.8, whatever you want to use that's close to 2. And it's just negative because there's a negative there. Oh, yeah, all right, I'll get there. My bad. Okay, sorry. 3.14. We got to classify it, right? Just got to approximate it. All right. What about 3/2? That's right. How many times does 2 go into 3? 2 times. How many times does 2 go into 3? Not 2 times. 2 times what gives you a number that's below 3? Let's do 2 times 0. 2 times 0 is 0, right? 2 times 1 is 2, and 2 is less than 3. So that's 1 time with 1 left over. So it's going to be 1.5. So 1.5. All right? The last one's good to go. All right, what's the lowest number? I think -2 is actually further left than the square root, because -2 is actually less than -1.7. So -2, then our negative square root of 3. Do we have any other negatives? One more. -0.321. Now our 2 positive numbers. What's going to go next? Very good. So 1.5, which is 3/2. And finally, pi. So again, I would say the biggest thing that students forget is to make sure they use the original numbers or symbols in the problem. All right, when you order it, make sure you use the original stuff. Any questions on this process? Okay, all right, so let's go ahead and stand up and let's try.